In this video, I'm going to show how to do some of the problems from the Chapter 4, Section 7 worksheet, which is on coordinate proof, just kind of an introduction to coordinate proof. We could do a lot more than this than what we're going to do, but we're just going to kind of start it. All right, so the first part is how you want to put your figure in the coordinate plane. So if they ask you to put a square in the coordinate plane, or a rectangle or a triangle, you want to think about where to do that. You really could do it anywhere you want. You could put the corner at 4, 3 if you wanted, and then go up from there. But think about where it would be the easiest to place it. I usually do this, the first option. Keep the figure in quadrant 1 by using the origin as one of the vertex. That's what I almost always would do. Another option would be to put so that the center is at the origin, because then you have this nice kind of symmetric figure. Another idea is to do this bottom one. This is a good idea too. Center a side of the figure at the origin, and then you could also use the axes to make the figure, which of course is a nice way, and then you still have one of the vertices is at the origin. Why do we want to use the origin? Because then one of our coordinates is 0, 0, and then your other coordinates are easy to find because you would just move over on the x-axis and up on the y-axis. So here's some examples of a problem similar to what you're going to be asked to do. It said to place a rectangle with a length of 8 units and a width of 3 in the coordinate plane. So they put, one way they did was center the long side so that it's on top of the x-axis and 0, 0 is in the middle of it. And then you're going to have to say like what the coordinates are. So if it's 8 long, you would put 4 on the left and 4 on the right. This is the way I probably would have done it if I was given the option, where I would put one of the vertices of my rectangle right at 0, and then 8 units over, I just have to move over to 8 on the x-axis. And 3 units up for the height, or the width, means you go up to 3, and then you figure this out. All right, so for your problem, you are going to, it says first to draw a square with a side length of 4 units. That means every side of your square is 4. And it says then to label the coordinates of each vertex. So you have to tell me what the coordinates are when you're done. So one way you're going to do it, number 2, is you're going to use the origin as a corner. So you would start right here, and then you would go over 4, and then you'd go up 4, here, and you draw a square. And then you would just say what each coordinate would be. One of them would be 0, 0. One of them would be 4, 0, one would be 0, 4, one would be 4, 4. I'm going to do this one. Center one side at the origin, 0, 0. And to do that, I have to, if you're going to use the word tools, let me move this down so I can show you. You're going to go to Insert, Shapes, and then get the line tool. It's under Lines, Line tool. Okay, I'm going to try to move back now. And then it has to be 4 units long, so I need 2 on the left and 2 on the right. So it's a little kind of skinny, but that's okay. And now I have to do that again. I have to insert another line so I can go up. 1, 2, 3, I have to go a little higher. And then I have to, every time you have to grab this line tool, it doesn't stay there for you, at least not on mine. So I have to keep going back and grabbing it. That's all right. Okay, so mine's, maybe I should have made my lines a little fatter, but I think we can see it. And then the coordinates of the vertices, whoops, I shouldn't have hit, there. I'm going to hit a return here so that I can get down to some space. One of them would be at, what's this point here at? It's at -2 on the x coordinate and 0 on the y. My font is quite small, but next is, I'll go over, that would be 2, 0, 2 on the x and 0 on the y, and then I'll go up here, and this point would be 2 for x and 4 for y, so 2, 4. And then my last point, I didn't do this one up here yet, is at x is -2 and y is at 4. Now you still need to do number 2, but you'll do it the same way, except you're going to put it over here. All right, moving on. If you do not have a specific length, but you have a variable, you're still going to do the same thing. However, this says to position a square with length m in the coordinate plane. So I gave you a coordinate system with no numbers on the bottom. You get to decide where m is going to be. But it's a square, so if you decide that m should be over 3, then it also should be up 3 units. Now, I'm not saying m is equal to 3. I'm just saying that I need to pick where m should be. So I'm going to center it, not center it, I'm going to start at the vertex. And I'll just go over this far, however far that is. Now that's 1, 2, 3, 4. The only reason I'm counting the units is so that I can make my up part a square. 1, 2, 3, 4. And now I'm drawing my square. Now, students will have different sizes it'll look like for this square. But what I'm saying is that right here, let me get my pen tool for a second. Come on, pen. Pen tool. Oh, here it is, pen. No, I don't want that. I want a pen. Pen. Okay, this point right here is at m for x. And on the y-axis, this point is at m. Why is it all shaded in? It's like colored. There we go. So then my coordinates are going to be, well, the corner is at 0, 0, that first vertex. Now the next one right here, I went over m units and up 0 because it's right on the x-axis. So that's at m0. Yeah. Now what is this point right here? This point is over m on the x-axis and up m on the x-axis. So that's at m. And then the last one that I didn't do yet is on the y-axis. I'm over 0 and up m. 0, m. Oh, I forgot the 0. There we go. All right. Now for this number 4 and 5, you have to they already placed the figure. You just have to figure out what's the missing value here. So you figure out what's the x value right here. It's over n, and it's up how far? It'll tell you right here. And on this one, it's over how many. You can look at this one to see it's over how many, and you can tell that it's not up anything. It's 0 for the y value. Okay, I'm going to let you do this one by yourself. You're going to go through each of these steps to try to explain why we can prove that the perimeter of the small rectangle is only half as big as the perimeter of the big rectangle. So you're going to be finding perimeter. Remember when you count the perimeter, because perimeter is length all the way around the figure, you're going to count 1, 2, 3. This is 4 wide. It's not 5. You don't count the endpoints. You count the bumps up. 1, 2, 3, 4. And then you count over. Now when you do this one, it's almost the same thing, but the difference is that we don't have numbers for our coordinates. We have variables. So the first one says to find the coordinates of B, point B up here. So that's going to be similar to what you've already done. The x value of this point, you go straight down and you can see that C has an x value of 2L. That's going to be the same as for B, 2L. So the first part here is going to be 2L. And the y value, to find the y value, you go straight across and you'll get the y value from this one here. And that'll be the y value. Now, to find the perimeter of A, B, C, D, you have to add the 4 sides together. Well, how wide is this first side here? It's from 0 to 2W, so it's 2W wide. How long is this thing? It's from 0 to 2L. But there's 2 more sides. We also have to add this side, which is going to be another 2W, and this side, which is going to be another 2L. So you'll have, I'm just going to do an underline so you guys can finish it. And then you'll just add your like terms together and you'll get an expression. Now you're going to use the midpoint formula to find the coordinates of E and F. You don't really have to use the midpoint formula. You can just say, okay, E is halfway between 0, 0 and 2L, 0. What's half? This is 2L long. What's half of 2L? 2L plus 0 is 2L. 2L divided by 2 is just L. the x-coordinate of E is L. What's the y-coordinate? Well, it's on the x-axis, so the y-coordinate is 0. So that's an L. It doesn't look like an L, but it is. Let me see if I can change my font to something cursive looking. There, now it looks like an L. Okay, now you're going to do the same thing for F. You're going to say, okay, what's the x-coordinate? Well, it's 0 because it's right on the y-axis. And the y-coordinate is found by taking half of 2w. And then G, you'll already know what the x-coordinate will be from E, and you'll know what the y-coordinate is from F. And then you're going to find the perimeter of DEGF, this little one, by adding the length, which is L. So you'll have L plus, and then you'll add the width, which you'll find in this one, plus something. Plus you'll have another L, plus you'll have another something. And then you'll combine your like terms to see you'll have like 2L plus something something. And then you'll compare your answer for 13 with your answer from 11. And you'll see if 13 is half as big as 11 is. And a hint is that it probably will be. You don't have to do the extra credit. You can look it over and try it if you want. There is some directions in the book about how to do this, but if you want to skip it, that's fine as well. All right, I hope this helps you complete this assignment. Good luck, and let me know if you have any questions. Thank you very much.